In the field of education, effective learning design is crucial for fostering student success. Two fundamental frameworks that guide educators in developing impactful learning experiences are Understanding by Design, also known as UBD, and Bloom's Taxonomy. Both frameworks support intentional learning outcomes, ensuring that instructional strategies align with desired educational goals. This video will examine the backward design process of understanding by design and how the use of Bloom's taxonomy can help to develop measurable learning objectives that support instructional design and ultimately student success. Understanding by Design was developed by Grant Wiggins and Jay McTighe. Understanding by Design emphasizes the importance of planning educational experiences with the end in mind. This framework is structured around three key stages: identify desired results, determine acceptable evidence, and plan learning experiences and instruction. UBD encourages educators to think critically about the purpose of their lessons and the experiences they provide, fostering a more student-centered approach to teaching, essentially working backwards in developing their lessons. Bloom's taxonomy, created by Benjamin Bloom in the 1950s, is a hierarchical framework that classifies educational goals into different levels of complexity. Originally, it was organized into 6 categories: knowledge, comprehension, application, analysis, synthesis, and evaluation. In the 2001 revision, these categories were updated to remembering, understanding, applying, analyzing, evaluating, and creating. Bloom's taxonomy serves several purposes that will be examined later on in this video, such as guiding curriculum development, designing assessments, and encouraging critical thinking. The Understanding by Design framework, developed by Grant Wiggins and Jay McTighe, is a powerful tool for educators aiming to create effective and meaningful learning experiences. This framework is built around 3 distinct stages that guide teachers in planning and assessing their instructional approaches: identify desired results, determine acceptable evidence, and plan learning experiences and instruction. In the first stage, educators focus on what they want students to understand and accomplish by the end of a lesson or unit. This involves setting clear learning goals and outcomes. Wiggins and McTighe explain in their article titled Understanding by Design Framework that this stage is about having clarity about the priorities they have for their class. They lay out these priorities through long-term performance goals. Teachers ask themselves questions like, what should students know? What skills should they demonstrate? What enduring understandings do we want them to take away? By identifying these desired results, educators can ensure that their teaching is aligned with meaningful objectives and promote deep understanding and retention. If we look at an example from Wiggins and McTighe's article, in the subject of history, there can be the long-term performance goals of applying lessons of the past to current and future events and issues, and to critically appraise historical claims. From these long-term performance goals, teachers would develop essential questions to hone in on what students need to learn in order to meet those long-term performance goals. So, in a geography class, students could be expected to understand how the geography, climate, and natural resources of a region influence the culture, economy, and lifestyle of its inhabitants. Therefore, the teacher develops an essential question such as, how does where we live influence how we live? The essential questions make those long-term performance goals measurable. The second stage revolves around assessment. Here, educators decide how they will measure student learning and understanding. This stage requires teachers to create assessments that will provide evidence of students' mastery of the desired outcomes identified in Stage 1. This could include various forms of evaluation, such as tests, projects, presentations, or portfolios. To be effective, these assessments must be aligned with the learning goals and should be designed to offer insight into students' comprehension and skills. Wiggins and McTighe break the assessment piece into two types: performance tasks and other evidence. In performance tasks, students utilize six identified facets to apply the information to new and real-world situations. They should be able to explain concepts in their own words, interpret data and texts, apply information into new contexts, see things from a different perspective and show empathy for those various points of view, and use self-knowledge to be able to reflect on their own learning. These six facets don't have to be used in every assessment and should be used at the end of a unit, not on a daily basis. The second type of performance tasks are categorized as other evidence. These are your traditional methods of assessment: quizzes, tests, essays, and so on. Regardless of which performance tasks are used, Wiggins and McTighe state that they should help with the alignment between stage 1 and 2 and ensure all important goals are appropriately assessed. The final stage is where educators plan the actual learning experiences and instructional strategies that will help students achieve the desired results. This involves selecting appropriate teaching methods, resources, and activities that engage students and facilitate their learning. Teachers consider how to present information, foster discussion, and provide opportunities for practice and the application of skills. This stage emphasizes the importance of designing lessons that are interactive and student-centered, ensuring that students are active participants in their own learning process. These are your day-to-day lessons that transfer information. Examples would be activities such as guided practice to analyze poetry, group discussions, and writing workshops. As we know, the development of effective learning objectives is crucial for fostering student growth. Another influential framework that supports this is Bloom's Taxonomy, created by Benjamin Bloom in 1956 and revised in 2001. This framework serves as a guide for educators to structure learning objectives and assessments, progressing from lower order to higher order thinking skills. Bloom's taxonomy is hierarchical, meaning that it organizes cognitive skills from the most basic to the more complex. Educators can use Bloom's taxonomy as a tool to develop learning objectives that are aligned with their instructional goals. By clearly defining what students should know and be able to do at each level, teachers can create assessments that accurately measure student understanding. This alignment not only helps educators track student progress, but also ensures that students are challenged appropriately, promoting deeper learning. At the base of the taxonomy are the lower order thinking skills, which include remembering, understanding, and applying. These skills focus on the ability to recall facts, understand concepts, and describe ideas. For example, in the remembering and understanding levels, students might be asked to memorize a list of historical dates or explain the main idea of a text. These foundational skills are important because they establish a base for further learning. As already noted, Bloom's is hierarchical, so students must learn at the lower levels in order to learn at the higher levels. In the applying stage, students use information they've gained in new situations. In math, students would be at the applying level when they solve word problems using formulas they have just learned. As we move up the hierarchy, we encounter higher order thinking skills, such as analyzing, evaluating, and creating. Analyzing involves using knowledge in new situations or drawing connections among ideas, such as comparing and contrasting different economic systems. Evaluating requires students to make judgments based on criteria. Creating involves combining elements to form a new original work, such as creating a project that integrates various sources of information. An example would be for students to design an experiment to test a hypothesis. Bloom's taxonomy is a valuable framework for educators seeking to enhance their teaching practices. By understanding and applying this hierarchical method of cognitive learning objectives, educators can effectively guide students from lower order thinking skills to higher order thinking skills, fostering a richer learning experience. So, can Bloom's be integrated into UBD? Implementing Bloom's taxonomy within the UBD framework not only clarifies learning objectives, but also helps educators create assessments that are aligned with those objectives. This structured approach leads to more meaningful learning experiences as students engage with the material at various cognitive levels. Using Bloom's levels to define desired results in understanding by design fosters a comprehensive understanding of content. Educators can enhance their teaching strategies and ultimately enrich student learning, preparing them for real-world challenges. Both understanding by design and Bloom's taxonomy are essential tools for educators aiming to create intentional and effective learning experiences. UBD focuses on backward design, ensuring that all teaching strategies are aligned with the desired outcomes, while Bloom's taxonomy provides a structured approach to developing critical thinking skills. Together, educators can use both frameworks to enhance student learning and foster a deeper understanding of content, incorporate various assessment types, and adjust instruction based on student needs. By integrating these approaches into their practice, along with regular reflection and revision of teaching strategies, educators can significantly improve the educational experiences they offer.